Well, good evening. Excellent. Oh, a live crowd. I love it. Welcome. My name is Drew Desker. I'm the director here at the Kopernik Observatory. It's great to see such a great turnout on not such a great weather-wise outside, but we're going to have some fun inside here. I also want to welcome those watching on the live stream. Well, anyway, I always do this. Who's here for the first time or not since your 4th grade field trip? Okay. All right. Good. Who here are members? All right. A good portion of the rest of them. All right. Well, very cool. So for the people who haven't been here in a while, the people who raised their hands second have a special knowledge of a valuable knowledge, actually. They have a Kopernik membership, and a Kopernik membership gets you into any of our Friday night programs for free. It'll get you into a number of special events that we offer, but also we belong to what's called the Association of Science and Technology Centers. It's a consortium of over 380 other science centers that will honor our Kopernik membership. So if you like this kind of place, it's actually very cost-effective. I think for a family it's $75. And again, you can get into any of those 380 other science centers for free, and you get to skip the long line, get people getting their tickets. In fact, I recall taking my daughter to the Franklin Institute down in Philly, and had we just paid the street price for just the two of us, it was going to cost us more than our year membership. So if you like this kind of place, it's worth investing in it. So we just finished our 50th anniversary. It was starting to be built in 1973 and was actually opened in 1974. Last year we had a wonderful gala down at the Doubletree Hotel, and we had a Nobel Prize winning chemist, Dr. Stanley Whittingham, as our keynote speaker. And the fact that we were still around after 50 years, I think, is a testament to the foresight that people had of what this area needs as far as a place that people could come and expand their knowledge. We're not always trying to turn everybody into an astronomer or an engineer, but it's an opportunity for us to actually learn something that we never knew for the first, when we first walked in the door. We do a number of things. We do right now we're in the middle of our school field trip season, and so sometimes it's quite active here, which is great. And we then this summer we actually will be our 33rd year that we do our STEM summer camps, where we just opened the registration. I think was it a week and a half? No, week ago. Yeah, actually about 2 weeks ago. We're already half full. And in fact, tomorrow we have a special event called Brain Day, where we're going to be partnering with the Binghamton University Psychology Department. Some of the grad students will come up here and engage the public in various brain activities. They'll actually have some brains on display for people to look at, and also it's an opportunity to have them meet some of our educators for our summer camps. We've had summer camps where we've actually had our students talk to an astronaut on the International Space Station using ham radio. I do a camp called a Return to the Edge of Space, where our students will build a payload with cameras and science experiments, put a weather balloon on it. It takes that payload up to over 100,000 feet. The balloon will finally burst, and then most of the time gently returns to Earth. Yeah, most of the time. Last year, not so much. But if you want to know more about that, come tomorrow to Brain Day. I'll tell you more about that. But every Friday night from March to mid-December, we always do a public program, and which is what we're doing tonight. And it's an opportunity for us to continue our lifelong learning. So especially those people that are on the younger side, notice all the gray hair back here. This is really education is really a lifelong pursuit, and so here that's what we do. Always on our website, we talk about what's going on. So tonight's program about Venus and Lucifer. Our Brain Day is tomorrow, and then here's the information on our summer camps. But if you go to our classes and programs, go to where is it? public programs. So tonight is, well, actually 3 weeks ago, we had a talk on spring skies. On Pi Day, we had a talk about math, the game of paradox, the most irrational number. Last week, we had a talk on science and religion and how they don't necessarily always conflict. Next week, the Fermi paradox. It's actually something that I just learned. I didn't realize Fermi had some thoughts, so you got to come back next week for that. Then we'll have a talk on AI. So again, not everything we do is always on astronomy. So it's an opportunity for us to really investigate the whole area of science and engineering. One of the other things we do is we live stream all of our public programs, and this started back in 2020 when COVID hit, and it became so popular that we just continued to do it even after we were able to return people to to gather together in an enclosed space. And now we've got over nearly 14,000 subscribers to our YouTube channel, and in fact, many of them are watching from literally around the world. There's a woman in Adelaide, Australia. Say hello to Lindsay. There you go. She's actually having breakfast right now in Adelaide, Australia. So, but anyway, so what's also nice about it is that you can actually go to our YouTube site and you can actually look at the previous presentations that we've had. Not only have we done presentations on Friday nights, but whenever there's any kind of an astronomical event, like the lunar eclipse a couple of weeks ago, we will do that. And in fact, actually, if you go there, Jenny, our live stream astronomer who's driving the live stream here, did a really nice 1 minute time lapse of the eclipse. We'll take a quick look at this. Well, actually, let's try it. Let's try it again. Here we go. So these were images taken here. Using a C-star telescope, which actually we can probably pull up a little bit later on just so you can see what that's like. We just changed the exposure, so now we can see it as we're approaching total eclipse. And we were very fortunate we had great skies that night. And Jenny was here literally all night. Jenny clocked out at 7 in the morning. So these are the kinds of resources that we offer here, and are accessible to you as well. So hopefully you'll take advantage of that. And again, one of the nice things about this is that even if you can't come up on a Friday night, you can watch it live. As I said, like Lindsay is in Adelaide, and all the people who are watching this evening. So again, we're very fortunate to have such great presenters. Some of them will zoom in, but we're very fortunate to have just extraordinary presenters that share their knowledge. And we're tonight, our presenter is Peter Klimas, who is a physics teacher. And I think if I had you as my physics teacher, I might have chosen a slightly different career path. But anyway, Peter loves talking about astronomy, astrology, and how you'll see he's not a static speaker, right? I know he's got a couple of his students in here this evening, so welcome to you as well. And so, Peter, the floor is yours.
Drew, thank you, and thank you to all of you for being here tonight. Are we live out there? All right. So, thanks to everybody who's watching and everybody who showed up here tonight. I have developed a fascination with what I call astronomy, mythology, and the keeping of time. And there is this intersection of the science of astronomy and all of the myth. Tonight, a little provocatively, we've got Greek and Roman, but also Bible stories that I'm putting into this category. But also the keeping of time, because Time and motion, I think, are tied up together. And the motion of the heavens is how we keep time. And so whenever you talk about the motion of the heavens, you're also bringing in the way in which we keep time in our calendars and the way that time passes for us here on planet Earth. And so right in the intersection of these three things, I'm very proud to say this is the third, this will be my third attempt at a Astronomy, Mythology, and the Keeping of Time talk. There's another one that I've called The Seven Gods of the Sky that I presented earlier this year. And another one that I did maybe 2 years ago at this point called The Marriage of the Sun and the Moon, about lunar and solar cycles and how we've developed our calendars around those. But all three of these have to do with this, what lies, I think, in this really interesting intersection in the middle. So tonight's talk is going to be in 4 parts, and we're going to start with the largest part, which is ancient astronomy. Then the goddess, Venus, medium-sized, Lucifer, also a medium-sized part, and finally the last part, modern astronomy, will be the smallest part actually tonight. Because it's the ancient astronomy that I find the most interesting, much more so than the modern. So part 1, this ancient astronomy part, is a Earth-centered astronomy. Because whether you're like, no, geocentric, that's out, right? It's heliocentric, that's the model. Yeah, but when you go outside to observe the sky, you're always looking at it from a geocentric point of view. And that even if you say, well, no, that's not the real thing, it is always going to be our thing. It's always going to be our point of view, and it's going to where we approach the sky from. It's actually the heliocentric view of astronomy. I would call it's a derivative, right? It's like a second order from what we experience. And the experience of going outside is what's up in the sky, where do you see it, and how do you see it from our Earth point of view. So to introduce, when I created this talk, I said, I've got to go back it up, Pete. Your mind is on fire with all these ideas. Let's go back up to an early place, and let's just look at some pictures in motion. Sometimes in astronomy picture taking, people do not like the motion, right? They want to get a real crisp image. But I actually find images in motion to be really interesting. I think that having some of the motion in the image makes it more interesting than less interesting. And so let's take a look at some sky pictures in motion. Like this one, this elapsed time image where the shutter stays open for an extended period of time. And this picture right here means that when you're looking at the sky, you're oriented looking north. This is north right here. Because when you look to the north, now you're like, for an observer in the northern hemisphere, this is true. For us here at Kopernik, for New Yorkers, we're in the northern hemisphere, and so what we see is when we look north, we see the circumpolar stars, stars that are going around the pole star, which is in the middle, Polaris. Now, if we have this picture, right, which way are we looking?
East.
I would say we're looking north. Because you're, again, seeing stars that are going around. Now, it's off, and it's a little bit to the left there, but we're looking mainly north. And you could argue that, hey, this picture maybe is at a more northerly latitude, because the height of Polaris, the center of this big wheel of stars in the sky, is equal to your latitude. And so for us here at Kopernik, 42-degree latitude, 42-degree altitude up off of north is the center of the celestial sphere, the sphere around which the stars seem to orbit, or they do orbit. I mean, for us, from our point of view, that's around which the stars are going. And you would say, well, that's because the Earth is turning, but from our point of view, it's the stars that are turning, and they're turning around that center part, which is north. Now, if you saw star trails that looked like this, you would be looking to the south, because you've got stars that are arcing, they're rising and they're setting, and that the center of that circle is below the horizon. Below the horizon is that center, and only if you went down into the southern hemisphere would you be able to see some of those stars that go around that southern celestial pole. Here in New York, there's some stars that we will never see. And in the ancient texts, there's people that journeyed more and more south. They took these voyages, and there's a new sky that opens up that you can never see from our point of view on the Earth. This right here, we'd be looking? South. Yeah, you getting the game? South. Now, what about this one? This is Half Dome in Yosemite. But where are we looking? We are looking to the east from a northern hemisphere's point of view, our point of view, because those stars are rising and they're arcing up. See if I could do backwards here. They're arcing up. Now, if you're looking south, to your left would be like more to the left of the screen as you kind of turn, that's east. And these are 2D pictures. They're flattened from what's really 3D all around you. So off to that side. And look at those kind of slanting up and to the rights. And oh, look, slanting up and to the rights. That's to the east. If you saw some star trails that looked like this slanting the other way, you would say, hey, this is where we're looking, to the west. And then I saved the most advanced example for last, and we're getting the hang of this. In this one, in this guy's opinion, we're looking... I would say, ooh, you see the center, right? There's like a big center wheel off to the upper right center wheel. I would say this is like a northwest right here. We're kind of see some of that arcing up into the top corner. We're seeing some of that slanting over there. I'd say northwest. All right. So this is what we're seeing. This is what the stars are doing. And the stars are fixed in their constellations. The stars are always the same patterns, although they do move across the sky, as I was just showing you. They show up in different positions, but they show up in the same star map. But Venus is a part of 3 special groups. And one of these special groups that Venus is a part of that makes Venus special is that there are 7 things in the sky that wander amongst the stars. There are 7 planets, ancient planets, that are seen with the naked eye. And that's what ancient astronomy is about. It's like prior to the telescope. We don't need a telescope to see these things. You and I can go and see them with no fancy equipment right now. And I keep an eye on, I try to go out and I observe. We actually got a new puppy this summer. And this pup, Jerry, he wakes me up in the middle of the night. And last night I was woken up in the middle of the night. And I actually have come to love it because I was outside. I didn't even set my alarm. Jerry woke me up for the lunar eclipse. I saw the lunar eclipse. And you go out in the middle of the night and you see things and you see the sky change, and like depending on it's 4:30 in the morning, 2:30 in the morning, right, what the sky looks like and how things are happening. And there are 7 things that are wandering up there. They're moving around. And lately we've been able to see Mars has been up, Jupiter has been up, until very recently Venus has been up. Venus has been up in the sky. There are 7 ancient planets. Now, some people would take issue with these 7 ancient planets because they would say, oh, look at that guy over there, Saturn, Jupiter, Mars, but the guy in the middle, Sol, who's that? The sun. The sun is one of the ancient planets because it doesn't do what the stars do. It wanders through the zodiac constellations. Over the course of the year, it moves through the stars. And you would say, well, we see different stars. Exactly, because the sun is moving. It's shifting through the stars, and what's out at night shifts over the course of the year. Venus, okay, good, Mercury. And then off to the side, this is the Latin L. It looks like a V-N-A, but we would say L-U-N-A, Luna, holding the moon. And off to the side, Septem Planetae, the 7 planets, the 7 ancient planets that wander through the stars. And one of those is Venus. Venus is a part of this very special group. Now, group number 2 is the brightest natural objects in the sky. Number 1, what is the brightest natural object in the sky? Ooh, it's the sun. Good job. All right. What is the second brightest natural object in the sky? Is the moon. Good job. And the third brightest light in the sky is Venus. And you read then the description of this talk tonight because I put it in there, all right? It's the third brightest thing in the sky. Now, what about the 4th brightest thing in the sky? It is, I heard it. I've heard it muttered out there. It is Jupiter. Now, this is on average, all right? Because these lights, like think about the moon, for example. The moon really waxes and wanes. It really varies how much light it's giving off. And so does Venus, by the way, and so does Jupiter. But on average, it's the sun, the moon, Venus, Jupiter, and finally fifth is the first star, the brightest star in our sky. Sirius, the dog star, all right? Orion's dog lagging behind, chasing Orion across the sky. Orion rises and the dog chases him in Canis Major. Sirius is the fifth brightest thing in the sky. Now, there's some other, though, kind of exceptions that I want to include because these lights change. Mars is going to tie Jupiter, but tie Jupiter on average because Mars really varies in brightness, whether it's closer or farther from the Earth. And so Mars at its brightest ties Jupiter average. But Mars is not on the top 5 list here, but like it could be, depending on the moment. And Mercury also would beat the dog star. It would beat Sirius, and that would only, though, be at its brightest. If you did the average values, then for the average values, Mars and Mercury, not on the top 5 list. But there's Venus, group number 2, special light in the sky. Now, thirdly, Venus is part of another very special group, which is lights in the sky that are never too far from the sun. And so here you've got only two that are in this group, Mercury and Venus. The maximum angles from the sun at which we observe Mercury and Venus, both planets can at times be observed at the sunset, or they can be observed at the sunrise. Mercury is never observed more than 28 degrees from the sun, and Venus is never more than 48 degrees from the sun. So these two lights in the sky, these are only evening or morning lights. You will only see them then. And you will never see them opposite from the sun, which you will see for Mars and Jupiter and Saturn. Those lights will be across from the sun entirely up in the midnight sky, but never these two. Now, this begs a question, though. In this diagram, it says that you can see these at sunset, at sunrise, but which is which? Yeah? If Venus is on that left side of the sun there, is that an evening star status or is that a morning star status? And if it's over to the right of the sun, is that an evening star status or is that a morning star status? And I found this to be a tricky one. Ooh, this is a tricky one, yeah? Oh, yeah, now, what's our vantage point? Well, in this picture, what the heck are we looking at? We're looking at the Earth, and typically it is customary to call it a, quote, top view, that you're looking down on Santa's house. You're looking down on the North Pole view. You're looking down on what the heck is down on the solar system, from a North Pole view, above the solar system, if you will. There's the Earth in the bottom of the picture. There you got that sun, and there you got Venus. But I don't like to think from this like, spaceman's point of view, if you want, right? I like to think from the Earth's point of view, that we are at the center, and it's everything else that's happening around us. It's our point of view that is the ancient astronomy point of view. And so I want to develop this with you into 2 quick steps. Hey, look, this is the sun. Which way are we looking? Just like those arcs of the stars in the sky, we're looking we're looking to the south. You're seeing this rising and setting sun. This was taken from the Griffith Observatory in LA, but you're seeing that arcing in the sky. We're looking to the south. Now, here is the sun arcing across the southern sky. From a northern hemisphere point of view, we have a sun arcing in the southern sky. And if you went over, we're looking to the south. If you went over to the left side, if you were looking south, and this is a flat picture, but really it would wrap around you, off to the left there would be the direction called? East. And over on the right-hand side, we've got the direction called? West. West. Good job. Okay, so now, wabah! There's the picture. Here you are looking at the sun. If you were over on this side, Venus, would that be an evening or would that be a morning star? It would be an evening star. Okay? Now, by process of elimination, if it was on this side, it would be a morning star, but maybe you don't believe what I just told you. Let me show you something else. Let's have that sun set. Let's rotate the sun so that we set the sun, and if Venus was on that side that I first asked you about, it would be the evening star side, because you see the sun sets, it gets out of the way, and then the sky gets dark, and there's Venus in the evening sky. And if we rotate that thing through another 180 degrees and have it come up on the other side, now the rising sun here would come up and it would wash out this bright light in the morning sky, Venus. That side is the morning star side. That you would see Venus as a morning star if it was on that side of the sun. Okay. Yeah, yeah. This is coming back. This right here comes back, and then comes back, and then it comes back. All right. This is a picture I took. My iPhone 10 is old technology now, and I couldn't take this picture with it. But my wife's phone, right? She's got all the fancy gadgets. It's got the new like night setting, and you can have it set to be like 1, 2, 3 seconds. And then even though you're just wiggling out of control, all of the photo processing technology behind the scenes, it lines up all of the photos that it was taking over the 3 seconds, and it puts them on top of each other, and it neatens it up for you, and it's like, there's your picture. I took that on November the 26th, last year, 2024, but not too long ago. Yeah, November, December, January, February, March. Here we are at the end of March, 4 or so months ago. And that light in the sky is Venus. Yeah, that's Venus. Evening star, 5:25 p.m. The sun had gone down, and there's Venus. You can still see a little bit of the glow of the sun setting there in the picture behind the trees. I like this picture a little bit better. This was on November the 2nd at 6:33 p.m. Took that beautiful shot of Venus as an evening star. Venus has been an evening star for us. And there you can really see that glow from the sunset. Now, these are screenshots from Stellarium. And what I decided to do was I went through a couple months. This is October the 1st, last year, 2024. And I decided to come out in Stellarium 1 hour after sunset. So I looked up the sunset times. I went 1 hour after the sunset because at the sunset, it's too bright. You can't really see much in the sky. It's all washed out by the sun, even in the simulation. But here you're starting to see some stars come out, and you've got Venus 1 hour after sunset on October the 1st. Boom, November the 1st. 1 hour after sunset, you can see that Venus has shifted in its position. December the 1st, January the 1st, 1 hour after sunset. February the 1st, the moon's getting into it, and March the 1st. Now we're going to go, I didn't want to do this, hold on. Let's go back. You can see this progression of Venus through October, November, December, January, February, March. You can see the swooping of Venus as it takes a different position in the sky in the evening time. You can see this kind of loop-de-loop pattern that it's making with respect to the sun. Because the sun has always gone down. An hour goes by every time I was consistent. An hour after sunset, you're seeing that. And what's happened now, we're here, it's March 28th. And we're about to go into the next month. This is March the 1st. April the 1st. It's coming up. And April the 1st, Venus becomes... Wait, what the heck are we looking at? In Stellarium, I can turn off the ground. So we can look right through the ground. And when we look through the ground, there's the ground. You can see west there and northwest there. When we look through the ground, the sun is set. It's a little bit underneath the horizon. It's an hour after sunset, just like I was doing. And Venus has moved to the other side of the sun. Wait for it. There it is. Venus has moved to the other side of the sun. Venus has moved into the morning star. It is now a morning star. You got to go all the way around the Earth, all the way up on the other side through the underworld, and up comes Venus before the sun. I have not seen Venus as a morning star. I have a terrible view of east from my home. I've got a great, much better view of west. So I've been really seeing the evening. I've been appreciating it. But the morning star, it's just barely up before the sun. I don't know if anybody has a good view or looks out for these things, but I'm not sure. I'm pretty sure you can see it in the right circumstances at this point, but I haven't seen it myself. Now, this is a different view of what I just showed you. This is an ephemeris of Venus between those dates that I just talked about, between October the 1st and April the 1st. This is what Venus has been doing. Venus has been marching through the constellations, and that very first dot in the bottom right-hand corner is October the 1st, 2024. Every 5 days we do a dot, 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 5 days, 5 days, 5 days, 5 days, and Venus has now taken a position where it is in the picture on April the 1st. That's where Venus is. Now, it's been marching through. It's wandering amongst the constellations. But this is a confusing picture because the sun is also in this picture, but that's where the sun will be on April the 1st. And the sun has not been there the whole time. The sun was also moving. The sun was moving through the constellations, and it was chasing Venus through the zodiac. The sun was behind Venus, and it was chasing, and the sun just passed her. The sun just passed Venus. Venus has now been in this little back movement in retrograde. There's a against the motion of the sun's normal progression through the constellations. And if you know your zodiac constellations, you can see that the sun and Venus move through Libra, followed by Scorpius. This is like October, November, through Sagittarius, December, Capricorn, Aquarius, Pisces, and now the sun has passed and Venus is moving to that other side of the sun, the morning star. So, morning star, you'll start to see Venus. And Venus will rise up into the sky at morning time. So maybe go out 1 hour before the sun rises, 1 hour before the sun rises, go out 1 hour before the sun rises. And what you're going to see is Venus is going to march its way up higher and higher in the sky over the course of the months. And then it's going to fall from grace down, down, down. Another thing that you can see in this diagram is that those lines that are sticking out from the Venus dot represent the brightness of Venus. And that the brightness of Venus starts out real bright in the morning when you first see it as a morning star, and then it dims over the course of time. The opposite happened as we were seeing it in the evening. Over the course of October, November, December, it was dimmer and then was brighter and brighter and brighter as it marched its way through its evening star status. And keep in mind that as this happens, the sun is shifting across the horizon because months are going by. The sun is shifting. All right. Now, you could plot altitude and azimuth. This is our point of view from the Earth. You could plot, just like I did in Stellarium, where Venus is. And these are taken from a book, The Venus Cycle, as played out on the theater of the sky. You could plot Venus in the east, that's that first picture, and then you could plot Venus in the west, and you would see these little swoop-de-loops that it makes as it rises up and then falls back down into the ground, into the underworld. And one of those cycles, I think this was kind of a cool little diagram, one of those cycles, it's customary, to start a cycle somewhere. Where do you start the cycle? Well, in the case of the moon, it's customary to start in a new moon. But you can start it anyway. It just goes round and round and round. Like, where do we start the year? January 1st. Like, I don't know, why do we do it there? Like, well, it just goes round and round and round. You can get into the circle wherever you want, but it's customary to start on the morning star side, and 263 days, approximately, for morning star Venus. Then it disappears, and it's gone for about 50 days. You can't see it because it's lost in the glare of the sun. But it reemerges as an evening star, and this is what we were seeing this past winter. The pictures I was showing you was the evening star for about 263 days. But the transition that has just happened from evening star status to morning star status, which has just happened, it only takes about 8 days. And this is very curious, this unevenness to the cycle, right? It's not even. There's an evenness in the presence of it in the sky, but there's a very unevenness in the absence of it in the sky. And it's just mysterious, and it's curious, like you wonder why. Now, if you kept doing this, morning star, evening star, morning star, evening star, we're going to read from left to right, from top to bottom. You would say, okay, there's one. There's two cycles. That is the top row, morning, evening star. We go to the second row. There's your third cycle. Then you do your fourth cycle. We got these neat loop-de-loop shapes that it's making. And then we go to the fifth cycle, down there on the bottom row. And when we get to the sixth cycle, we should notice that that sixth morning, evening star cycle is the same as the first one. That Venus repeats, but only after 1, 2, 3, 4, 5 cycles as a morning and an evening star. It repeats then its presence exactly in the loop-de-loop shapes. 5 Venus cycles and the pattern repeats. Now, if you added up all those days that I gave you of the morning star, it's gone, evening star, it's gone, it's 584-day cycle that Venus goes through. And that cycle times 5 gives you 2,920 days. You convert that into years and you get, boom, 8 years. 8 years. Almost exactly. To the ancient astronomer, it's freaking 8 years. It's exactly 8 years. Well, it's not exactly. It is exactly 8 years to the ancient astronomer. Now, you could think about this in terms of 8/5. I said, what does 8/5 have to do with Venus? Well, there's 8 Earth years per 5 Venus cycles. There's, in other words, 8/5 is 1.6. 1.6 years between Venus reappearing as an evening star. That's the length of time that is the Venus cycle. But you could also flip that over and say 5/8. That Venus keeps 5/8 time. That Venus is 5 cycles per 8 Earth's years. In other words, there's 5/8 of a Venus cycle per year. Now, this is crazy, okay? This is a crazy picture. But we're at the center. That central dot is the Earth. That's our point of view. We are the Earth. That is the center dot of the picture. And that loop-de-swooping pattern is Venus. You can see the sun going around the Earth. The sun goes around the zodiac constellations. But you can also see that Venus is loop-de-swooping through the zodiac constellations that are way out there. What's way out there in this picture? The constellations, the stars. And what are those swoops that come in toward the Earth? Those are the closeness of Venus to the Earth. Those are the inferior conjunctions, where the Venus goes in front of the sun. And you could swoop-de-loop through and see that from one inferior conjunction to the next inferior conjunction, you've got, I love this word, I had to think about it, a biquintile. What the heck is a biquintile? Well, a quintile would be a fifth. So a biquintile would be 2/5. And if you took 2/5 of 360 degrees, you would get 144 degrees exactly. It's 2/5 of 360. And then, in other words, when you draw a star, think about drawing a star. Start in the bottom left corner there and draw the star. You skip one of the points to do from the bottom left corner of your star to the top point of the star. And then you skip that point that juts out to the right side and you go down to the bottom right corner. When you draw a star, you kind of skip around, and that's exactly what Venus does in its inferior conjunctions around the zodiac constellations in the background. Boom. 8 years. Now, it's also curious that another player up there takes a special role. That this 8-year Venus cycle, it's even more mysterious because it synchronizes with the moon. 99 moon phase cycles occur in an 8-year period. And you're like, well, it's like a day and a half off, but that's pretty darn close. The ancient Greeks, they used this 8-year cycle. They called it the octiteris, and they married the sun and the moon. This was my other talk that I gave here, the marriage of the sun and the moon. This was an important cycle because it's so dang close. The moon's 99 cycles really sync up with the seasonal cycle of the sun, and rituals for festivals and ceremonies, including the Olympic Games, they included scheduling on a full moon, but you didn't want the seasonal festivals to shift through the seasons. So you wanted to have some things at the same time of the year, sun-wise, but you also wanted to sync it up with the moon, moon-wise, and you wanted calendars that are in sync. But 99 moons do this, and it's also an 8-year Venus cycle. It's like everything, all the celestial clockwork is all in sync. Now, you could also plot that angle thing that I was talking about. Here is the snake in the middle is Mercury, and the longer swooping snake is Venus. And this is just plotting the angle from the sun. And something that you can notice in this plot is that there's a faster part, which is the transition from the evening star to the morning star status. It happens quick. But then it's slower part. You can see all those X's closer together. There's a 50-day time period when it disappears from the morning sky before you see it reemerge in the evening sky. There's an unevenness to it, and it's just a curiosity. All right, so to finish up this long section on Venus here, the ancient astronomy, there's 7 Venus, I'm going to call them reversals, to use some of the more mythological language. Like, what is Venus switching back and forth in between? Just shout out, you know, it's switching back and forth in between. Yeah, evening and morning, right? It's like a morning star, evening star. But it's also switching back and forth in between ascending up into the heavens, getting higher and higher in the sky at sunset, and descending down during the sunset times. It's also getting dimmer and brighter, okay? There's a brightness and dimness cycle. There's also it's visible, it's there, you can observe it, and it's gone. It's just not there, you can't see it, it's invisible. It also moves faster and it moves slower. It also shifts westward and eastward across the horizon, something I talked nothing about, but it's like getting even more advanced. Where does it set and where does it rise on the horizon? It'll move across westward and eastward and westward, and it'll have extremes. And finally, Venus even goes through phases like the moon does. There is a waxing and a waning of the disk of Venus as we see it from the Earth. All right, so that completes part 1. And this sets us up, I think, to understand some of the mythological understandings of Venus and Lucifer. All right. Venus is special, part of 3 special groups. By the way, the planet names that we use are from the Roman mythology. All right? And so the Roman mythology, this goddess is Venus. But it's sometimes called Greco-Roman mythology, and so the Greek counterpart to Venus, because the Romans believed that everyone was Roman, that really in their hearts everyone was a Roman, and all these people that they conquered, these cultures of the world, right, they were just Romans at heart, and their gods were these other gods. They were just Roman gods in disguise. The people called them by different names, but they were Roman, all right? And so the Greek goddess that was Venus is Aphrodite. And the Norse goddess, who is Venus, is Freya. And this was a 7 Gods of the Sky talk that I did. And by the way, this goddess, we name one of the days of the week after her, Freya's Day, Friday. And it's more apparent in the Spanish and the French, Viernes, Venus's Day, Vendredi, Venus's Day. Yeah, it's Venus's Day. Now, this goddess, Venus, is the goddess of love and beauty. All right, those are the classic ones. We got them right here, 2, right out of the gate, love and beauty. But I would also say to you that when you wish upon a star, it's probably Venus, because the 3rd brightest light in the sky, the brightest star in the sky is Venus. Right? The only thing that outshines Venus is the sun and the moon, but those are clearly different. This star in the sky that is Venus, that is the brightest star. If it's going to be an evening star, Geppetto here is wishing on the evening star. Now we got to do this. Let's try it. All right, it's unavailable. We're making it happen. I set it up. But, oh no, it's right here. Good. Let's listen.
Make my wish come true.
Make my wish come true. Yeah? It's right there. I love the stuff that's hidden in plain sight. It's been there, and it's always been there. And make my wish come true. And take the brightest stars up in the skies and place them in her eyes for me. See, it's all there, this imagery of Venus being this bright star in the sky. It is the brightest star in the sky. It's not just one of the brightest. It is the brightest star in the sky. And make my wish come true. Now, I would also argue, though, that when you wish upon a star, the evening star, Venus, you're wishing to fulfill your heart's desire. Yes. And we must not forget that regardless of how we feel about it, when we look at the old texts, we are reading history from a decidedly male point of view. And from a decidedly male point of view, near the top of the list, or maybe at the very top of the list, is a lovely lady to fulfill your heart's desire. A lovely lady like Aphrodite, the Greek counterpart of the goddess Venus. The goddess of desire. Aphrodite is the personification of a deep-seated and irresistible desire in men. We got to listen. We're going to try it. It's going to happen. This one happens sometimes.
It got me on a mountain top, was burning like a silver flame. The summit of
Beauty and love.
and Venus was her name.
She All right. Now, even before, right, the Romans had Venus, we go back to the Greeks had Aphrodite, but even deeper seated than that is we have the Sumerian and Babylonian empires. And Sumerian-wise, there's this goddess Inanna, and Babylonian Ishtar from the Epic of Gilgamesh. And this right here is Inanna Ishtar, the queen of heaven, the goddess of love, but also war. Look at those weapons on her back, and fertility. Accompanied by, in the upper left-hand corner there is the sun. Venus is always accompanied by the sun. And you could see the horned helmet and those weapons and those, like, I don't know what, wings, right? What kind of wings are those? I'm not sure. But there she is. Do you see her? Who's that? Inanna Ishtar, Venus. And what is Venus doing here? Well, Venus is heralding, is welcoming this guy. He's cutting his way up through the mountains, and he's emerging from being behind the mountains. Who is this guy? Well, it's the sun. Is Utu or Shamash, these are again for these different names, just like the Inanna Ishtar name. We've got the sun that's coming up, and there's a third guy in this picture here, and the third guy is Enki, or Ea, the water god. And so it's curious that you've got the Venus and you've got the sun and you've got this water god. And we've got another ancient, right? King Melishapak II, the 8-pointed star was Inanna Ishtar's most common symbol, dating to the 12th century BC. I wonder why it was an 8-pointed star. Have you figured that out? Because the Venus cycle is 8 years. So that 8-pointed star right there is Venus. And in the middle, that's clearly a moon. And over on the right-hand side, what is that thing? The sun. The sun and the moon and Venus, the 3 brightest lights in the sky. Now, here you've got this beautiful Homeric hymn about Aphrodite, the birth of Aphrodite. But remember, Aphrodite is just this Greek counterpart to Venus, the birth of Venus. Of August gold-wreathed and beautiful Aphrodite I shall sing, to whose domain belong the battlements of all sea-laved Cyprus, where blown by the moist breath of Zephyrus, you can see Zephyrus, the west wind spirit there, blowing her across the gentle waves. She was carried over the waves of the resounding or loud moaning sea in soft foam. The gold-filletted Aura, the hours or the seasons, there they are. They're welcoming her and clothing her with heavenly raiment. The clothing and the beauty of the naked body I see as the brightness and the dimness of Venus. And you see, right, kind of this imagery. Ooh, look in the background there. Who's that peeking up? Who is that peeking up? That's the sun. And over on the left-hand side, right above Zephyrus's head, is maybe that really bright star in the sky heralding the rising sun, Venus. Now, we've got Sandro Botticelli, the birth of Venus. Maybe the quintessential, the most famous Venus. Blown by the winds of Zephyrus, clothed by the seasons. There's Venus floating in on the sea. Water. The water god, yeah, was there. And there's this birth of Venus in the water. And here is Aphrodite's legendary birthplace in Paphos, Cyprus, where Venus came into existence. And the legends aren't always consistent with themselves. You can contradict the mythologies, but one version of the mythology is that Aphrodite was unlike the others. Aphrodite was just born of the sea. It wasn't born of the gods. Zeus wasn't the father of Aphrodite. It was just Aphrodite came into being. And here's a scene from Lady Gaga's music video, Venus. Once a year, Aphrodite returned to Cytherea and dived into the sea from which she had come. Sparkling and young, she rose from the water as dewy fresh as on the day when she had first been seen. When Venus first emerges as a morning star and rises up out of the sea. If you lived in the Mediterranean, you got lots of water around to be witnessing these things on the horizon, and Venus rises up out of the sea and gets morning after morning higher and higher in the sky before falling back down and becoming an evening star. But this is in the water she goes and emerges back up into the sky as a morning star in the morning, the starting place of the cycle, the birth of Venus. Here is Venus and that water scene, right? You see that water and Venus rising up out of the water. Now, Venus, desire, beauty. When, I got to get my names right, Aphrodite, we could say Zeus, but Venus, we would say Jupiter. When Jupiter, or when Zeus saw Aphrodite, who had just come into being from the sea, he knew that there was going to be trouble. He knew there was going to be trouble because all the men gods she was irresistible to. And so he married her off to Hephaestus, or Vulcan in the Roman mythology. And Hephaestus was a good boy. He actually didn't like it when his parents, Zeus and Hera, argued, and he got into the middle of the fight one time, and Zeus chucked him out of Mount Olympus and broke his legs, and he was always hobbling around from then. He wasn't a very attractive man, but he was a beautiful craftsman. He could make the most beautiful things. And so, even though Venus was married to Hephaestus, she had an affair with Mars. And Hephaestus, he suspected this, and he wove this net that was unbreakable, this metal net, and he caught them in bed together. And here he is, peeking in on Mars and Venus. Desire likes the bad boy. But Venus and Mars, here they are. Do you see them? Making babies. This is back in 2021, Mars and Venus. They will appear just a half a degree from each other. There is a conjunction of Venus and Mars. And the babies of Venus and Mars are Phobos and Deimos. Fear and Panic, the moons of Mars. Now, to finish this off, there's a great story of Cupid and Psyche. These are the Roman names. Cupid is Eros, is the son of Venus, of Aphrodite. And this little guy with the arrows, when he shoots someone with one of those love arrows, the next person that they look upon, they fall madly in love with. And there's a lot of this, this is very problematic, all right, for people in the stories when, Venus promises to have Eros shoot someone with an arrow. But in the story of Cupid and Psyche, which we're not going to go through today, but in the end, Psyche ends up spilling some hot wax on Cupid and really burns him and injures him. And Venus plays the part here of the protective mother. Venus is very upset with Psyche, this beautiful goddess mortal that rivals her in beauty, and she's ticked because Psyche hurt her son. So what does she do? She sends Psyche through all sorts of crazy, impossible tasks at the end of the story. And Psyche, she has to sort out all the grain, all the millet and barley, sort all the grain into the different, piles. And there's this quote, Venus at the approach of twilight returned from the banquet of the gods, breathing odors and crowned with roses. Venus returned at twilight. Isn't that interesting? And then on another impossible task, sending Psyche to the underworld with a box full of, quote, beauty, because that's what she told her was in the box. Don't open it, by the way. Don't you dare open this box full of beauty. Be not too long for your errand, for I must paint myself with it to appear at the circle of the gods and goddesses this evening. Again, Venus is going to appear in the evening. And with that, part 2 is complete. Part 3, Lucifer. Now, this statue that I'm going to have in a lot of these slides is called the Genius of Evil. And it was put up in a cathedral in 1848. And it is, I think, a fantastic version here of Lucifer, of Satan, of the devil. All right, so where does this idea of Lucifer come from? Well, if you go just to the heart of it, if we just jump right into it, where does Lucifer come from? The word Lucifer is mentioned once in the Bible. And it's in the book of Isaiah, chapter 14, verse 12. How art thou fallen from heaven, O Lucifer, son of the morning? How art thou cut down to the ground, which didst weaken the nations? And so there's this mention of Lucifer. Lucifer is from, in the King James Version of the Bible, it comes from the Latin translation, which was translated from the Hebrew. And the Latin translation, Lucifer literally means the light bringer, the morning star. The star that you see, when all the other stars have been washed away by the rising sun, there's this one star left, the brightest of them all, that is there to herald the dawn. And that star is Lucifer. That star is Venus. That's that bright light in the sky. That Lucifer means the light bringer, that Lucifer brings the light. Lucifer is still there as a morning star when all the other stars have been washed away. Now, if you go back another step to the Hebrew, there is this, and I am no Hebrew scholar or biblical scholar. This stuff just fascinates me. Halel. This is the word that was used, that was translated into Lucifer, but the Hebrew word might be better translated as the shining one, the morning star. And so then you have all these kind of similar names for the same thing here in the translations. You have Lucifer, the light bringer, the shining one, the morning star, the son of morning. But all of these are references to this light in the sky that is left to herald the dawn. Venus. But Venus as a morning star, it's not mentioned here really as an evening star. It's its morning star status that seems to be part of this, eight-pointed star, Lucifer legend. Now, if we want some more context, if we go back before that verse that I just read you in the book of Isaiah, a little bit of context here is that people poo-poo this and they say Lucifer is not the devil. Lucifer here that was referred to is just this mistranslation of the Hebrew, and it just means the morning star. And look, Isaiah is not even talking about the devil. Isaiah is talking about the king of Babylon. That thou shalt take up this proverb against the king of Babylon and say, how hath the oppressor ceased? The golden city ceased. The Lord hath broken the staff of the wicked and the scepter of the rulers. That this Lucifer reference is to the king of Babylon. It's not to the devil. But broken the scepter here. There in the statue, in the hand, is the broken scepter. And there in the hand is this crown, the fallen king. All right, this fallen king. And on the ground is the other half of the scepter, which has a star on it, and the apple with a bite at it, the apple from the Garden of Eden, the apple of the knowledge of good and evil. And so there's this theme of pride versus humility in all of Christianity, that the cardinal sin is pride. And one of those main ways to be a good Christian is by being humble. And so there's the pride and there's the humility. It's in the morning star. And that the morning star is brightest as it rises, but as it falls, it gets dimmer and dimmer and dimmer. Now, if we go on, hell from beneath is moved for thee to meet thee at thy coming. Hell from beneath. Where is Venus going? Venus is going 50 days vanished into hell. When Venus sets there for the last time, when you can't see Venus anymore in the morning, it's gone for 50 days before it reemerges. It's gone into the earth, into the underworld. Hell from beneath is moved for thee to meet thee at thy coming. It stirreth up the dead. Even the chief ones of the earth it hath raised up from their thrones. All they shall speak and say to thee, art thou also become weak? Ooh, like Venus is becoming weak. Thy pomp is brought down to the grave. How art thou fallen from heaven, O Lucifer, son of the morning? How art thou cut down to the ground? Lucifer is falling out of the sky day after day, month after month, and is eventually in the underworld, in the dead. Now, on the rising side, book of Isaiah, I'm just keep reading the verses. For thou hast said in thine heart, I will ascend into heaven. I will exalt my throne above the stars of God. There's this pride that Lucifer feels better even than God himself. This prideful feeling will be punished. I will sit upon also the mount of the congregation in the sides of the north. I will ascend above the heights of the clouds, yet thou shalt be brought down to hell, to the sides of the pit. And so there's this idea of disobedience to God, that Lucifer rises thinking that Lucifer can rise all the way up into the heavens like the sun does, but Lucifer cannot. Lucifer is not God. Lucifer is brought back down into the earth. Now, as a fun little tidbit, this statue that I've had, is Venus a beautiful woman, or is Venus a beautiful man? I mean, devil, right? There's this idea of beauty in both cases, that these statues, right, they're very attractive versions, right, of a man that are these statues in the churches. And it just so happens that this the statue that we've been looking at is a replacement for the sculpture that was considered simply too sublime to represent the devil. It was too much of a distraction for the local girls who came to gawp at Lucifer over there on the left, instead of listening to the sermons. The one that we see today was sculpted by, I can't say, Giefs, and the talent for marble ran in the family. The original commission had gone to his brother, Joseph. Joseph's work, The Angel of Evil, was put in place like 5 years later, but it caused an uproar and it was immediately removed after just 1 year. This idea of the goddess of desire here in the form of Lucifer. Final part. Modern astronomy, all right? Modern astronomy. So today we would say that, hey, the sun is the center of the solar system, not the Earth. And that the reason why Venus doesn't get too far from the sun is because it's an inferior planet. Its orbit lies within the orbit of the Earth. So we're always looking at it from the outside. And that it can only get to those angles over there on the left and over there on the right, the eastern elongation, that extreme angle, and the western elongation, the extreme angle, where there's the inferior conjunction where it has disappeared. It has disappeared because you can't see it in the glare of the sun, or that superior conjunction, it has disappeared. You can't see it in the glare of the sun. But to expand on that same diagram, it also then makes a little bit more sense why those disappearance periods are different from each other, that the one is shorter and the other is longer. That here in the inferior conjunction, there is only an 8-day disappearance, but on the back side, there's a longer disappearance in the glare of the sun. You can see it in the geometry. You can see it in the angles. And you again have this kind of symmetry on either side of that, but you have this asymmetry on the disappearance periods between morning and evening and morning. There's that diagram. You got Venus on one side or Venus on the other side of the sun. Now, this was a diagram that, to me, brings it all home. I've memorized this in my mind, and that all of these things that I've talked about tonight in terms of Venus and astronomy, and if you want to go out and observe it and you want to understand what's going on, this diagram right here is my go-to. I made it up. Did you know that the planets go around the sun counterclockwise? There's that counterclockwise rotation from a top view, from a North Pole view. And we are looking at this orbit of Venus from the outside. And you've got this fast transition in the front. You've got this brighter and dimmer status. Why brighter and dimmer? Because Venus is closer and farther from the Earth. And so the proximity here matters, even though counterintuitively, Venus goes through phases. And when Venus is closer to the Earth, it's actually in a waxing crescent phase. So less of it is illuminated, and you're like, oh, dimmer. But the part that is illuminated is so bright that it outshines itself when it's around the back of the sun, when it's farther away. And so this here kind of explains so much about that Venus cycle. But I think that the cycle is more fascinating the other way. It's more fascinating the ancient astronomy way. By the way, the modern astronomy way would say, hey, well, with respect to the stars, the sidereal period of Venus is actually 224.7 days. It takes Venus 224.7 Earth days to go around the sun. And that means that that special 8 Earth years for the cycle to repeat is 13 of those orbital periods of Venus. So we go around the sun 8 times, 8 years special. But Venus goes around the sun 13 times. And that means that Venus passes us 5 times. It's overtaking us 5 times, which are the 5 evening morning star cycles of Venus that then repeat when we get back in sync within like a day and a half in 8 years. Now, I'd like to finish tonight with just some comments about what this means to me, why I find this interesting. And I read this book with my kids, The Indian in the Cupboard, and I found it a great novel because it left this idea, the main theme was kind of always left unsaid. But to me, in The Indian in the Cupboard, little boy puts the plastic Indian in the cupboard and it comes to life. And there's this theme of things versus persons. And when it was a plastic toy, it was a thing. But when the cupboard made it came to life, it was a person. And that Omri, the little boy, I think just inherently knew the difference. That this person had to be treated differently than a thing. And some quotes, right? The fun of keeping the things. He was not a very tidy boy in general, but he did not like arranging the things in the cupboard and the drawers and then opening them later and finding them just as he left them. But when Omri sat up sharply in bed, he peered into the dark corners. He saw him. But he wasn't on the shelf anymore. He was in the bottom of the cupboard, and he wasn't standing upright. He was crouching in the dark corner. The Indian was scared. He came to life. He was half hidden by the front of the cupboard, and he was alive. There's this difference between things and people. And what I'd like to suggest then is that it's much more interesting to think about Venus as a person. And I came across this panorama version of the song that we listened to earlier, Venus. And in this music video, I was like, oh man, it's all been done before. I don't have any new ideas, right? Lucifer and Venus, the sexy devil, right? That's exactly it right here. It's all of that imagery tied up into one. You've got all of it right there. And so I just wanted to then, we're gonna click past this. I'm gonna try to, Venus and Lucifer, let's get to that last slide. Here it is, right? Venus on a mountaintop. Yeah, Venus on a mountaintop. There it is, Venus. So I would say that there's more than one interpretation of the story that the gods in the sky tell. Is it Venus, sexy and alluring, flitting back and forth, constantly visiting with the other gods? Or is it Lucifer, the devil, whose pride comes before his fall? Is it Esther, a story that I didn't even talk about tonight? My mind was crazy with ideas, who is also the last light left while all the others fade away? Is it, as the Bible says later on, Christ himself, who leads the way to invite God the Father into our lives? Is it Ishtar? Is it Inanna? It would be incorrect to demand that an exact empirical observation of the planet's motion be translated into a mythological story. That would be putting our modern understanding prior to the ancient one. You see, the ancient one has to be taken on its own home ground, within its own context, to the best of our current ability. In fact, our current scientific age may present a barrier to seeing planets in this way, as persons, not as things. Science is a spiritual experience. We had a great talk last week about this sort of idea, that finding things out and understanding them, I think it creates more wonder in us, not less wonder. and that the universe was created in a way that it presents to us patterns, patterns that persist, patterns that can be discovered, patterns that can take 8 years of careful observation only to finally see that it represents a pattern at all. Patterns that provide the inspiration for the myth and our cultural stories that have been passed down through the generations. Patterns that reveal hidden mysteries in the stories. Patterns that can be interpreted in different but similar ways by people all around the world. I would say that these are the patterns that stir our soul. And this is what interests me about the astronomy and the mythology and the keeping of time all tied into the same knot. Thanks for being here tonight.
Well, thank you so much, Peter. Do we have any questions? Well, we do have one. Okay, so I'm going to do my Phil Donahue thing here.
Peter, I'm wondering, I had never thought of the ancient Hebrew as keeping any systematic kinds of astronomical records like Babylonians and stuff. Do we have evidence that they, in some sense it seems to be implicit in the text, but do we have any evidence that they ever systematically studied the stars?
So I know that, is this back on? I think so. My mic. I know that the most ancient records are from the Mayans and from the Babylonians. And there's these two, let me look up this name here. There is the Mayan Codex. There's this Venus Codex. And there's also the, where is it? This Babylonian record of Venus, right? So I couldn't say on the Hebrew. But I do know that these things got, there's aspects of them that I believe, this is my personal belief, that's like encoded in the myth. But I also believe that myth isn't the static thing. It shouldn't be like, but what did they say? But like myth evolves and changes. And that's why I included all of this more modern. I mean, you have these modern, Lady Gaga is doing a Venus video where she's being reborn in the water, just like the ancient Aphrodite myths, right? And they kind of evolve over time. So I couldn't comment on the Hebrew, but I feel like it's there. And tonight, one thing that I did was I'm already going over. I got too many ideas. They're all crazy. But in the Bible texts, there wasn't just the book of Isaiah, which I shared tonight. There was also the book of Ezekiel. And there was stuff in there that I could make a case for being Venus-like. And there was the Ark of the Covenant and the two cherubim angels on the sides that were, God sits between the cherubim, which is a psalm, and then you have all of the description of that in Exodus, and that it's like the two cherubim are like Mercury and Venus in between God and the center, the sun. And you've got these two angels on the side, which is the most holy place, like the way to experience God in the Ark of the Covenant. And you had in Revelation, there's like these texts as well about the serpent, which is the back and forth of Venus, back and forth on the sun, and the serpent is Satan. The serpent is the devil, and like it's all like intertwined into the same. So I couldn't say exactly, but it is my belief that the more I've read and studied mythology, the more I get at. It's not just about trying to. It's not about astronomy, just right. It's about those other things, but it's all tied together. That's how I feel about it.
All right, hold on. Get another question, then get you the mic. We do this so that the people on the live stream can hear the question.
Not really a question, but an observation after a lifetime of being a United Methodist pastor and studying the scriptures and so forth. You always got to remember, especially with the Old Testament, that there were a lot of things going on at the same time among the different cultures in the Near East. And Abraham came from Babylon. And the wise men in the New Testament came from the East, from Babylon. So the cultures are all jumbled together. And Ishtar is one of the goddesses that God got so upset with the Israelites for worshiping. You can't separate this stuff. I'm sorry, you just can't. And I think your way of coming at it shows how it all ties together. And I really like, the focus on the story, the beauty of the myths, and the reality of looking at the world around us, the universe, from where we are. Because quite frankly, unless you have access to some of these fantastic telescopes we're putting up in space, there's really not much other way you can see it, even when we look through the telescopes out here in the at Kopernik. And if we try to come to this stuff and divide it, and as the program last week pointed out, to treat it as if there is a war going on between religion and science, then we're really screwing ourselves. Sorry if you don't like that language, but that's what's happening.
Okay, thank you.
We do actually have a question from the chat. All right. It says, why is the transit of Venus on the sun 135 years and then 8 years later? For those that don't know, a transit is when one body comes across another. So in this case, the last transit of Venus was in 2012, and it won't happen for another 120 some odd years.
Right. So, and I'm aware we had 2 transits.
Right.
Right.
The Venus
Yep.
transits happened. In
And
pairs.
then we also, this same sort of pattern happens with eclipses, right? We had 2 recently here in North America.
There's one tomorrow.
And then we're not going to see in North America, I'll be dead. But I have a vague answer, but I don't have a specific one. And the vague answer is that we like to, our simple model is that the solar system is a plane. And that as a physics teacher, I can tell you that when all that gas and dust was pulled together by gravity, it's like the pizza dough being spun, and you have some rotational dynamics with the pulling together. And when that pizza dough gets spun, it flattens out. And so you have a flat solar system. But it's not actually perfectly flat, which is why we don't get eclipses of the moon or transits of Venus every time. We have slight tilts. And the moon I know a little bit more specifically about, which is that there's a 5-degree tilt to that plane of orbit of the moon with respect to the ecliptic, the plane of orbit of the Earth. And that means that there are 2 places where the planes cross each other, the nodes. And you have the head of the dragon and the tail of the dragon, to use the mythological language, but you have the 2 crossings of the orbit of the moon and the Earth. And so I would say that orbit of Venus is also tilted with respect to the ecliptic. It's tilted with respect to the Earth, and that you only get that transit when the Sun and Venus and the Earth's planes are all lined up. And this doesn't happen frequently.
Right.
However, these things tend to, I'm making this up now, but these things tend to precess. All right, I'm making up something that I know is also true in other circumstances. It might be true in this circumstance, which is that these planes precess. The plane of the moon certainly does precess. I know that for a fact. And I would assume that this wobbling of the plane also occurs with Venus. And so you have this lineup, but then we're kind of moving off of that nodal lineup, and we're not getting back into another kind of nodal lineup for a long, long time.
There was just a comment that in the 70s there was a progressive rock group called Starcastle, and their Fountains of Light was astronomy themed, and the song Portrait contained the lyrics, Venus raging her heart against the sky. So again, the 70s had great music. Didn't it? So anyway, well, unless there's any other questions, again, we always have a rule here. Oh, we do have a question. I apologize. Here we go.
Kind of like a observation of question 1. Now, if anyone's ever seen the cable show Lucifer, one of the observations I noticed, guys seen highlights of it, he was introduced earlier in the shows as Lucifer Morningstar.
Yep.
And not only that, here's the question: do you think Lucifer, Venus are tied into like just one metaphor, one thing?
Yeah, they are. So I would say that was kind of so Lucifer Morningstar also is in the Sandman comics, all right? Lucifer Morningstar, and the Sandman goes down to hell and meets Lucifer Morningstar. Lucifer Morningstar is a common thing because you're just repeating yourself, you know? what is it? It stands for Lake Lago. It's like Lake. You just do two different languages, right? So you got Lucifer, Morningstar. You're repeating yourself. You're saying Morningstar. And, but that's kind of, I think, my point tonight, which is that it's all tied up together. That Lucifer is Venus, that Venus is Lucifer, that these things are also that light in the sky that doesn't do what the stars do. It's all ultimately the same thing.
So, unless there's any other questions.
Thank you.
We were talking about eclipses earlier, and there actually is a partial eclipse of the sun tomorrow morning at 7:05. But here in Binghamton, it'll be maybe at maximum covered about, I think, was it 14 or 17% or something like that. So you've got, and the thing is, actual maximum eclipse will actually happen below the horizon. So we actually have to wait for the sun to come up. So if it's, right now the weather's not looking overly promising, but if you're up at 6:30, get yourself to a place where you've got a nice, really low eastern horizon. And you may get lucky and just see, if you got your eclipse glasses, right?
Solar glasses.
That you didn't really get to use back in April. So again, use those eclipse glasses and take a look. Now also, one of the things I always say when school groups come up here, we talk about looking at the sun safely, and that you never want to use your binoculars or a telescope to look at the sun unless you have a solar filter designed for those those binoculars or a solar filter. So do not put your eclipse glasses on and then grab your binoculars to look at the sun, because it's going to burn right through that film immediately. So you heard it from me for sure. And if you're interested, I can show you a pair of those glasses that when you put the eclipse glasses behind binoculars looking at the sun. We have them with a pair of holes in here. What I was going to say, though, is our rule here at Kopernik is you can't leave until you look through a telescope. Unfortunately, tonight's not going to be one of those nights. But if you paid to get in, you do get a card to come back. So I'm going to be out in the lobby, and so anybody who paid to come in, see me. I'll be happy to give you a complimentary card to come back on another evening. Doesn't have to necessarily be an evening that is come for the talk, obviously, but I would love to have you come back and look through our scopes. But I will also be happy to take you, especially for those who haven't been here in a while, or this is their first time, I'll give you a tour of the scopes. So let me see, it's we'll see about at 9:30 we'll start the tour. But anyway, thank you, Peter, once again for just an outstanding presentation. Next week, our talk is sort of the answer to the Drake equation, or the question to the Drake equation is the Fermi paradox. The Drake equation, if you recall, is there was a scientist by the name of Drake who came up with sort of a formula to figure out what's the possible percentage of intelligent life being out there. And the Fermi paradox is, why haven't we seen it? So come next week for that answer. And Dr. Stan Hunter is the one who will be presenting it. So we won't give any spoiler alerts, right? So anyway, thanks again, and look forward to having you come back again.